If the linear correlation between two variables is negative, what can be said about the slope of the regression line? So we already know that. But there's a new term here, regression line. So let's talk a bit about it. Regression line is the best straight line that can be drawn through a scatter plot. So this is an example of a scatter plot. The blue dots are representing a scatter plot. So obviously you can't draw one line which covers all these points, but you still, in many occasions, you want to draw an approximate kind of a line, which is as close to most of the points as possible. And so you see this red line is a pretty good straight line. It's probably the best straight line that you can draw through this data. And that's what the regression line is. So whatever kind of association or correlation you have between the variables, the slope of the regression line will be according to that. So if the variables are negatively correlated, then the slope of regression line will be negative. Given a set of data and corresponding regression line, describe all values of X that provide a meaningful predictions of Y. Now, a regression line is useful only to make predictions which for X values that are either within the data set. So let's go back to that picture. So we see here that the X values are ranging roughly between -20 and 60. So regression line will be useful for predicting X values, for predicting the Y's for those X's that are within this range or very close to it. So let's say you want to know what's happening at 65 out here. So even though there is no point for the 65, but you will have the equation of the line. And in that equation, you will substitute X equals 65 to make a prediction for Y. And similarly here, you can go a little bit below the -20, but not too far. So as long as you are close to the range of the original X values, which were in the scatter plot, then regression line can be used to make a useful prediction. But if I go too far out, let's say I want to use this line to predict what's happening when X is 100. Now that's too far away. So let's go back. Given a set of data and corresponding regression line, describe all values of X that provide meaningful predictions of Y. So according to what we just said, prediction values are meaningful only for the X values in the range of the original data or close to the range of the original data. Yeah. Is there a relationship between the raises administrators at a certain university receive and their performance on the job? A faculty group wants to determine whether job rating X is a useful linear predictor of raise Y. Consequently, the group considered the straight line regression model Y is equal to B0 plus B1X. So you are familiar with the equation of a straight line. You are mainly familiar in the form MX plus B. But this is also fine as long as you are writing it some constant times X plus another constant. So the way it's written over here, the slope will be beta 1 because whatever is the coefficient of X, that's the slope. So over here, the slope is beta 1. And the y-intercept is B0. Whatever is the isolated constant, that's the y-intercept. So using the method of least squares, the faculty group obtained the following prediction equation. Okay, so that's the regression line we just talked about. Interpret the slope. Okay, so we all have heard of the slope and y-intercept. So let's briefly talk about what their interpretation is. So slope is the change in y for each additional x. Y-intercept is the y value when x is 0. Okay. So slope is the change in y for each additional x. Now in this case, we can see that the slope is 2000. So recalling our interpretation, it's a change in y. Remember, y was the raise. So it's the change in raise for each additional x. So it's the additional raise you will get for each additional rating point, because rating point was x. So for example, what this is saying is that if you get one more rating point, your slope, your raise will be 2000. So every rating point is like getting $2,000 raise. So now let's see. For a $1 increase, no. The increase is in the rating point. For administrator with a rating of 1, no. It's the increase in rating. For a 1-point increase in rating, yeah, the administrator's raise is estimated to increase by 2,000, yep. What's the last one saying? For a 1-point increase in rating, the raise is, so no, that's saying decrease. So if the slope is positive, then each additional x will increase the y. So since this is positive slope, so with each additional rating point, the salary increases. Given the following least square prediction, y is estimated to increase, because if the slope is positive, then y will increase with each unit in x. And so y will increase 74 units with each additional x. That's what we just said slope means.